Now in this session, we're going to be going through building runtime applications using the Runtime SDK for Java. I'm Mark Baird, and I'm joined with my colleague Rachel Ellen, and we're both engineers on the Runtime SDK for Java team, and we're based in the Edinburgh office, which is based in Scotland. Now, before I get started, I just want to get a feel for who we have in the audience. So first of all, is there anybody who's completely new to writing runtime applications and you're looking to sort of learn about capabilities and get going? Anybody who's completely new? Oh, quite a number of you, okay. And what about people who are using the old version of runtime, so the 10.2.4 version, and maybe looking to migrate your applications to the latest version? Existing users of the SDK? There was one there, good. And what about people who are writing runtime applications looking to migrate over to ArcGIS Engine? Sorry, other way around, ArcGIS Engine applications looking to migrate to runtime? None. Well, that's good to hear. Well, I think we've got some good material for everybody here. So what we're going to do in this session is we're going to go through how to get started with the latest release of our software, which is 100.4. I will be talking a little bit about the implications of Java 11, a new version of Java which came out late last year, and also how we go about sort of bringing JavaFX into that latest version. And then we'll take you through some common classes and patterns that you need to work with in order to be able to sort of bring together basic mapping applications in 2D or 3D. We'll go through some common use cases. We can't cover everything inside the SDK here, but I've chosen graphics overlays and also to give you a brief overview of offline data. But you appreciate there's lots more capabilities available in our SDK, so this is just sort of a flavor to get you going. And then we'll finish off by talking about licensing and deployment so you can get your application ready for market so your own users can make use of that. And we'll take questions at the end. So a great place to get started if you're new to the SDKs is go to our developers website. So developers.arcgis.com, and we've got a landing page here for all of our developer technologies. So it could be you're wanting to write JavaScript applications or Android or iOS or Java or .NET, but we don't speak about that in here. So let's go and take a look at Java. So the Java landing page, lots of marketing resources here and telling you about the capabilities of the SDK. Lots of resources here to sort of get you going to put complete workflows together for the application. The guide documentation is a good place. There's lots of documentation there to explain how to write your first mapping applications, whether you're using Gradle or Maven or you're sort of wiring up jar files in your own IDE. And then we've kind of got documentation to cover common workflows for bringing capabilities into your own applications. And there are step-by-step guides to sort of bring that information into your own applications. Now, all of the API references there online, but of course the SDK does include a javadoc.jar file, so you can view the API reference inside your IDE, as you would hope. And then to complement the guide documentation, we've got a large number of sample code bases, a large number of samples, which are basically they're complete applications that cover common use cases in the context of a completely working application. Now, these are all available inside GitHub, so you can clone this repository and be able to run these applications in your own IDE, so you can see how these things work. Other resources we have with the SDK is we have all of the samples are bundled up in a sample viewer. So this is a Java application that you can download onto your own machine and be able to run the applications in order to get a feel for the capabilities inside the SDK. So you can experience it without having to use an IDE as well. And we also have a toolkit that we're building up. So in the previous release, the 10.2.4 release, we had sort of a fairly rich toolkit, but we've got two toolkit components in there at the moment, but we're looking to sort of build that up, and that's all open sourced on GitHub, so you can add things like north arrows or scale bars, and we're looking to extend those capabilities going forward. And then if you've got any questions on the use of the SDK or you get stuck, there is a support forum there. It uses our GeoNet platform where either one of us or another member of the community should be able to give you some help moving forward with any problems you may find. So there aren't any, I don't think we had anybody in the room who was using the previous version of the SDK, so I won't talk about what it used to be like. I'll say now that the SDK is just available in two ways. So first of all, if you're working in an air-gapped environment and in your development environment you don't have any internet connection, and that does happen with people working in certain industries, the SDK is available as a zip or a tarred gunzip file which has got all the required files so that you can wire the jar files up inside your IDE manually. It's probably more common that you'll make use of the Maven repository that we have that contains all of the files that we need. So you can basically use Gradle or Maven scripts to build your application. Gradle is quite a common way of building Java applications now, so I'll talk you through this workflow, but it's very similar in the other workflows. So what we have in the what we have is a plugin which will bring in all the resources that you need to write your own Java applications. Now, these come from bintrate.com, so this is a commercial offering, so this doesn't go into Maven Central. And once you've kind of got a reference to the plugin, you can specify the API version. 100.4 is our latest one. 100.5 will be available in about a month's time, and you can sort of go back and use any previous versions of the SDK, going back to 100.1. Now, if you're writing Java 8 applications, these are basically the only things you need to include inside your Gradle script. But if you're using Java 11, things are a little bit different. Out of interest, is there anybody who's currently using Java 11 in their applications? Okay, so the next slides will be of interest to you. Now, when Java 11 was coming out at the end of last year and Java 8 was sort of disappearing, there were a few quite alarming articles that were appearing on the internet. Things like, well, there's going to be an end of public updates for the JDK 8. Oracle are going to be charging for Java from January 2019. JavaFX is going to be removed from the Java JDK. Now, all these are quite alarming things, and they are all true, but there is a way forward, so it's nothing to worry about. So the statement here is that our current release of the software, 100.4, works with Java 8, as you'd expect, but it also works with Java 11. And there's a link at the bottom of the page here that explains how you can migrate your application from a Java 8 to a Java 11 runtime environment, because it doesn't just work. There are a few little problems that you'll come across. Now, the next release that we've got coming out, 100.5, will only work with Java 11. And going forward, we're going to be supporting the LTS, the long-term support versions of Java as they are currently released. And an LTS version, we're expecting to see those coming out every 18 months to 2 years. Now, there have been some licensing changes to the Oracle JDK, so if you're not careful, you may find yourself having to pay for the use of the Java runtime environment. So to allow people to be able to perhaps bypass that, if you didn't want to use the Oracle JDK, you can now choose your Java runtime environment of choice. So internally, we're making use of the Adopt Open JDK. You could just use the standard JDK or continue using the Oracle JDK. So previously we just encouraged people to use Oracles, but since the licensing change, we've now certified the product to work with any of those. And in fact, it's just a Java application. It should work on anyone, so it's not a problem. Now, the other thing you'll notice with moving with Java 11 is JavaFX is no longer available in the JDK. And the reason for this is it's been open source. It's still available, it's still maintained, and there are separate binaries available. And these are sort of moved forward by a company called Gluon now. So they are available and they are free to use. So as I mentioned, JavaFX is no longer part of the Java runtime environment. So if you take your Java 8 project and you sort of try to run it inside Java 11, you'll get error messages coming up saying, oh, can't find JavaFX. Well, it's actually fairly straightforward to bring these into your build script. So a little bit like us, the OpenJFX organization make use of a plugin that you need to add into your build script. And then in the JavaFX section of your Gradle build script, you refer to the version of the JavaFX that you're wanting to make use of, and you also need to make a reference to the modules, the JavaFX modules you want to build in. So if you remember Project Jigsaw, which was mentioned, whilst this was in development, this has now come to life, and we now have modules inside Java. Probably if you've got a very straightforward application, you'd just be bringing in JavaFX.controls into your application. Now, there is some very good documentation which I would encourage you to make use of on the Gluon website that does explain this in a lot more detail. So if you are sort of adding in JavaFX, or if you're making deployments, there is some good documentation there which will sort of get you through some little issues you might discover. So I want to now just introduce you to some of the key classes and the patterns that we make use of in making 2D and 3D applications. So I just want to start off by talking about the main two classes that you're going to be working with for writing 2D applications. Now, the first class, the map, or in Java we decided to call it the ArcGIS Map because obviously in Java map has been used elsewhere, so we didn't want to clash there. We have a class that represents the data that you're going to be working with inside your application. So really that consists of two things. It's a base map, which is the wallpaper, over which you draw your own business data. And this is represented by a group of operational layers. Now, these operational layers, they could be coming from ArcGIS Online or your own feature services, or maybe you're making use of OGC, web feature services, for example. You just put those into your operational layers, and that defines the data which you're going to be using inside your application. And then to visualize that, you need a JavaFX control. So this is our map view. So this is where you're going to view and also interact with your data for doing things like panning and zooming. You just associate the two classes together, and you've got a basic mapping application there. So as well as writing 2D apps, you've got the ability to be able to write 3D apps as well. So rather than working with a map, you'll be working with something called a scene, or an ArcGIS scene. It's actually very similar to a map. So we've got a base map, and we've got some operational layers, your business data that you want to visualize inside your application. But because we're working with 3D, we have the concept of a surface. So this will, when pointed to an appropriate service, would allow you to see the lumps and bumps and mountains, for example. And then to visualize that, you have a scene view. So this is the 3D viewing JavaFX control that you put into your JavaFX application. You just associate the two classes together, and that brings your application to life. Now, before we just move over to looking at some code, I want to just introduce this state transition diagram to you, which explains how we go about listing into resources that you may be working with that are not particularly fast. Now, what I'm thinking about here is network resources. Sometimes they're really quick and sometimes they're not. But one thing we don't want to be doing in our application is blocking the user interface thread in our application, waiting for a slow network resource to come to life. So we can wire up listeners to be able to sort of detect when certain events have happened, when we're working with disk I/O operations, or maybe loading new data into our application. So if we just take something simple like a data source, a feature service, which is where we may store points. When I first instantiate that inside my application, it's in a not loaded state. And then when I start interacting with that in my application, I've brought it into my operational layers, there's some HTTP communications that go on. And hopefully it's sort of making a connection to the endpoint of a server. So this has gone into the loading state. So the communications have started, and we're starting to get some feel for the capabilities of the service that we're working with. And then if all is good and we have a successful communications and we've got some data, some points that we want to display in our application, this goes into a loaded state. But if something bad happens, like I'm swinging my arms around and I whip the network connection out the side of my machine, this will fall into a failed to load state. And we can detect this programmatically in our applications and do something about it, like say, oh, you need to check your network connection and try reloading it. So to demonstrate some of these now, I'm going to hand you over to Rachel, who's going to take you through the process of creating a very simple 2D JavaFX application. So over to you, Rachel.
Yep, so let's just switch the screen so that we're working from my machine. So before I jump into the code and give you a talk through for how you would create a map with an application, and then on the screen I'll just show you the application that we're going to build first of all. So we have a 2D map, an ArcGIS map, with a base map rendered in the background with topography and labels. And on top of it here, this square of colourful panels is representing a geological map. And we are accessing this geological map via an ArcGIS online server, which we're bringing into our application as a feature layer. So now that we know what we're going to build, then let's hop in and take a look at the code. Okay, so the first part for building an application using for Java is to set up some boilerplate code for writing a JavaFX application. So these two lines here, you're setting up a stack pane and an application FX scene in order to display your data. The first step for creating a map for your application is to create a new map. So instantiate a new ArcGIS map, and you can pass into that a base map of your choice. Next, just like what Mark talked through there, you would create a map view, and the map view is the JavaFX control in which we actually display our map data. And then you would set that map, our ArcGIS map, to the map view. This would result in a nice, simple application which would show a map. Although because we know that we want to view our geological data, then we want to initiate our map on a particular point on the map so that we load with the geology map in place. We can do that by setting an initial viewpoint to the map, and we do that by instantiating a new viewpoint, which takes in a point, and we allocate an x coordinate and a y coordinate along with a spatial reference and a scale in order to open the map at a particular point on Earth. Okay, so the next stage is to go and actually get our data, the geological map. So as I said before, the geological map is coming via an ArcGIS Online REST service feature. And the way that we bring it into our code is to create a new service feature table and pass in the URL to that server. So you can see here we have the URL, which is pointing to our server, and we bring that within our service feature table. Next, to add it into our application, Mark has already introduced the concept of operational layers which contain the data for the map. So we need to go ahead and take that data from the service feature table and add it into a feature layer here using this code. So you're creating a new feature layer and passing in the data from the service feature table. This line of code here, set opacity, that is so that you can render the geological map on top of your base map, but still see the topography behind it. Okay, so we now have our data within the feature layer, and now we need to go ahead and add that into our operational layers. But it's nice and simple. You take the map, get the operational layers, and add in your feature layer before finally adding your map view to your FX stack pane. And then that will create the application that I showed you before we first started. Okay, Mark.
Thank you. So, I can spot a weakness in this application. So what would happen if we lost the network connection whilst it was loading that feature service data? So what would happen if I pulled your network lead out at the wrong moment?
Well, let's not pull the network cable out, just in case that causes everything to break. But what we can do is go into our URL and just break the URL manually by adding in this here. And if we go to run this demo again, then we can see what happens. And as it starts to load up, there we go. So it's loading up now. And as you can see, the map itself is still loaded. We still have an ArcGIS map, but we no longer have a feature layer. We no longer have our geological data in there, and we also have no idea why.
Silent failure, not good.
Never good. We would like our data to talk to us. So we can do that by going and having a look at the loading listener that Mark introduced you to earlier. So in this next demo, I have exactly the same code as what we have just run through before. As you can see here, we still have this URL talking to the service feature table. The URL is still broken. The only difference that we have in this code is that we are adding, in this line here, a loading listener to the feature layer. And what this is going to do is it's adding a done loading listener to the feature layer, and then we're going to get the load status of this feature layer. And we're going to print it out in the console window. So let's go ahead and run this app. And as it loads, we can see in this window down here, and let me just make that a bit bigger so that you can see it, the feature layer has failed to load. And that is what we expect because we've broken the URL. But that's good because now we know that it's failed to load, and so we can do something about that, like check to make sure our network cable is plugged back into our computer again. Or just by going back up to the URL, fixing the URL, running the app again. And then this time, when it's going to get the load status from that feature layer data, then you can see now in the console window down here that the feature layer has loaded. So that's really powerful because that means that we now know that the data has loaded successfully. And upon loading the data successfully, it allows us to programmatically enable any other user interface features within our map, such as being able to turn on and off particular layers, so particular geology layers or fault lines, for example. Okay, that's back to you, Mark.
Thank you. So it's also worth noting that the listeners that get fired here, and that you'll find them all over our API, they don't fire on the UI thread. So whilst we were waiting for that network connection while we were waiting for that feature layer to not load, Rachel could have been panning and zooming the map. It remains fully responsive whilst we're doing that. So we're not having a frustrated user by going, why is my application frozen?
Cool.
Okay, so the next thing I want to talk about is graphics overlays. So graphics overlays are used for displaying temporary information or maybe fast updating items. So examples of this, it might be that you've got an application and you just want to do a bit of redlining. You want to just scribble a circle on your map in order to be able to identify something. Or it may be that you're listening into a radio feed of fast-moving items. Maybe you're writing a situation awareness application and you're listening in to the position of things that are around you. And you don't want to be writing that kind of information into a feature layer, for example, because it's not going to be a very efficient way of getting that data into your application. So graphics layers are very powerful. They're extremely quick to update. We've had applications running with 100,000 points all moving around at a sort of a refresh rate of 20 milliseconds. It's a very powerful pipeline for moving graphics around very quickly. Now, they can be used for displaying points, lines, or polygons. It's basically exactly the same rendering pipeline that we're using for the feature layer. So the symbols that you're familiar with, the simple marker symbols, or maybe the 3D symbols that you've been working with, and the and the renderers, they're all the same. So the rendering capabilities are identical to your feature layers. You'll notice that the graphics overlays are part of the map view or the scene view. Now you may think, oh, that's wrong because the data side of our application is inside the map. Well, the reasons that it's in the map view and the scene view is this data is not persisted. So a map can be inflated in its entirety from something like a web map in ArcGIS Online. The graphics overlay information, that's just temporary data. You're entirely responsible for maintaining that because that's in-memory, temporary information that is not saved back to the map or the map view, so just temporary information. Now, in terms of the draw order, the way that we rendered this on the screen, The first thing that we draw when we're sort of going through a rendering cycle is the base map, your wallpaper. And then on top of that, we draw the operational layers, and then over the top of all that, we have our graphics overlays, which are drawn on the top. Now we have a demonstration which Rachel is going to do, where she's listening into a live feed of the location of an interesting satellite, which is orbiting clearly not above our heads at the moment, but let's go and take a look at this.
Yeah, so for the purposes of this demonstration for showing you a graphics overlay, then what you can currently see up on the screen is a single red circle. This red circle, though, is a lot more interesting than it first appears because it's tracking the live position of the International Space Station as it orbits the Earth. And we're accessing this data via a live internet feed. Right now, of course, it chose this moment for our presentation to be flying over the Pacific Ocean without any particularly clear topographic landmarks to help us realise where it is, but we can maybe track it later and get a better idea for where it is. From a programmatic perspective, what we're looking at here is again an ArcGIS 2D map. This time we're using a base map for oceans rather than topography so that we can see some interesting features like some fracture zones running through the Pacific Ocean in here. And then the graphics overlay, in which the red circle representing the International Space Station is represented. So let's go and have a dive into the code and see what's going on. Okay, so I'm just going to skim through these first few bits. We're just setting up a JavaFX application as before. We're creating a new ArcGIS map, and note this time we're using the Create Oceans base map, creating a new map view and setting the map to the map view. So the new bit of code that we have from the last demonstration is where we're setting up a new graphics overlay, and the graphics overlay is going to be the home of any graphics that we want to represent on our map view. So to add our new graphics overlay onto our map view, again a nice simple line of code here, get graphics overlay.add the graphics overlay. So we now have a graphics overlay that is set to the map view. It's currently empty, so we need to add something into it. So the way we go about doing that is to first of all set up a style for the graphic that we want to be adding into our graphics overlay. In this case, we're going to be setting up a simple red circle, as you've seen before on your map. We can do this by creating a new simple marker symbol, a class available within our API. And we're passing in a simple marker symbol style, this circle. We're using a hexadecimal ARGB code to represent the color, which is red. That's what this code looks like here. And then the size to represent the size of the circle. Now, in this particular app that I just showed you, we only have one graphic that is on the graphics overlay. So applying a style to one graphic isn't likely to take up a lot of memory card or graphics card resources. However, if you are having a lot of points within a map, say hundreds or thousands of points, then that's going to become quite heavy on your graphics card resources, and you might want to consider using a simple renderer. And a simple renderer, rather than applying an individual style to each and every single individual graphic, it will apply a renderer to a particular graphics overlay, so that any graphic that is saved within your graphics overlay will all share a similar style, and it will be much less heavy on your graphics card resources. So here, setting up a simple renderer, we're passing in our symbol style, this red circle, and then finally applying that simple renderer onto our graphics overlay via the setRenderer method. Okay, so now we have the style set up. Now we need to actually add a graphic in. The first stage of adding a graphic in is to get a new geometry, and in this case we're using a point to represent the space station. Now, because I'm getting the point data from an internet feed, that's buried within a method further down the code, which would be a bit too complex to show you in this presentation, then I've got an example of how you would set up a new point to represent an item on a map. So it's very simple. Set up a new point, pass in X and Y coordinates and a spatial reference to set up a point. And then to set up a new graphic, again, very simple. You create a new graphic and then pass in your geometry, in this case a point, into the graphic. So everything is set up now. All that remains is to add the graphic into the graphics overlay. And we can do that by this method here, graphics overlay, get graphics, and add in the graphic. You'll notice that within that application that I showed you, the map was constantly updating to show the location of the International Space Station. And this happens by updating the geometry of the graphic. So we can go and take a quick look in the code and see what's happening here. So to update the map to follow the International Space Station, I've set up a new timer, and the timer is being refreshed every second. And every second, the graphics geometry is being updated via the internet feed from which the International Space Station data is coming from. And if we just go back and have a look at an earlier running application that I had, so I actually started this application running when we first started the talk, so back at 4 o'clock. And the trail that you can see along here, this is representing the orbit of the International Space Station over the last half an hour or so. If we zoom into the data, you can see that in this case, it's tracking the ISS. So rather than actually following the map view and updating it live, it's leaving behind it a trail of red dots. At this point, that's quite a few hundred points, and it's just as well we use that simple renderer, otherwise our memory card resources would be, graphics card resources even, would be getting quite heavy. And just as a side, on this example, we've kept it fairly simple with a red circle to show you the International Space Station on a 2D map. But Tyler, who's in the audience today, he is our other Java developer, and he will be out in the islands in the showcase, and he can show you a really nice 3D implementation where you can track the International Space Station orbiting around the globe. Okay.
Thanks, Rachel. So this was just a very straightforward 2D application, but of course we can render that in 3D, and we can use 3D models, collada models, which could be for the International Space Station, or we've got a blue aeroplane flying around the Grand Canyon. So it just gives you an idea of some of the things you can do with graphics overlays, with a geology lesson slipped in too, I noticed there. So
couldn't help it.
Okay, so I just want to talk about something a little bit different now. So offline data, which is very important if you're taking your applications into the field where you don't necessarily have any network connection in order to be able to read your data. Now, I'm not going to go into this in a huge amount of detail because there is an offline session later in this week that sort of spends a whole hour talking about this, but I want to give you a flavour of the capabilities that we have for working with offline data. So there are two patterns that we support. So the first of which is what we call the services pattern. So this is where your data exists maybe in a web map in ArcGIS Online, or it could be your own portal, or it could be a feature service. And if you've set your services up so they're what is known as sync enabled, you can make requests to the data sources so that you can take an offline copy of the data and store it on your device so that you can view and also edit the data when you don't have any network connectivity. So you may be having some sort of a tough book that you're taking out into the field to record some new positions. You don't have any network connectivity. Now, when you do have your network connectivity back, you can perform a synchronization operation so that any changes that you've made to the data will be pushed back up to your enterprise data source, or your feature service, or your web map. But that synchronization process, it's a bi-directional process. So not only are you going to be uploading changes that you've made to the data whilst you've been offline, if somebody else has made changes to that same area whilst you've been offline, they'll also be downloaded back onto your copy of the data. So the end result is a copy of the data which is refreshed, ready to go out in the field the next day for doing some more data collection work. So that's quite a common and powerful offline story. Now, the other pattern that we support is if you've got your data in ArcGIS Pro. So inside Pro, you can export your data into a mobile map package. So this is the same format that we use in the services pattern, but this is for update-only purposes. So it's read-only, you can't change that data. But that works for many people for being able to take reference data out into the field. So if you're more interested in this, then do attend the session, or you can come and talk to us on the developer island about this afterwards. Okay, so I want to now talk about licensing and deployment. So you've written your application, which you're tracking satellites, or maybe you're doing offline editing, or maybe routing or geocoding, or any other of the capabilities we have. The next thing you need to do is license and deploy your app. Now, I'm not going to go into a lot of detail here as to what the different levels of licensing are, other than saying that we've kind of got Lite, which is a free-to-deploy license, and then there's increasing levels of cost associated with basic, standard, and advanced. Now, if you want to know exactly what is attached to those different licensing levels, do have a look at the License Your App page that we have here, and there's a table in there to explain how that works, or talk to one of us or one of our product managers. Technically, we need to license our application, so that license for developer use only watermark that you may have seen on the map is taken away, so that it's ready to go. Now, there are two approaches that we have to licensing your application. The first of which is what we call named user. So if you are a user of ArcGIS Online and you have access to an organization, or maybe you have access to your own portal internally, you can license your application by just simply logging into the portal or ArcGIS Online. Now, the second method that we have, because we recognize that not everybody is a customer of ArcGIS Online, is the license key. So this is where you can purchase a license key from customer services or your own local distributor, and you can burn that license key into your application. Or if it's a Lite application, then there's a free license code you can put into your app. So let's just look at the code. So I'm going to start off by talking about the license key to start with, because that's the easiest one. So this is where you get your license code from customer services. And then you're going to make use of the ArcGIS Runtime environment class, and then there's a static method on there where you're going to pass in the string that you've got, and that will unlock the capabilities of the SDK and get rid of the watermark off the map. And you'll notice that I'm calling that before I'm using any of the functionality inside Runtime. So I've called it even before I've launched my JavaFX application in the main class of my Java application here. Now, the named license method is where you log into ArcGIS Online, for example. So I've got some code here which represents extremely bad security practice, but it does demonstrate how to log into a portal very easily. So the idea is you will use the portal class to log into your organization in ArcGIS, and you'll pass in some credentials, and you will not hard code username and password into your application. You use something like OAuth, but this is just a nice, easy demonstration. So we pass in the credentials, and we're going to load asynchronously the portal. So we've got our asynchronous pattern going on here. So we're not blocking the user interface thread whilst we're waiting for ArcGIS Online to respond. We're going to listen in to this done loading listener. And what's going to happen here, if I just sort of move down to this line of code with my cursor here, is I'm creating a license info class, and into that license info class, I'm populating that with the portal, get portal info, get license info class. And then if we skip down to the very last line of code, I'm using my ArcGIS Runtime environment .setLicense to pass in the instance of the class that I've populated from the portal there, and that will unlock the capabilities of my application. The license for runtime only use will disappear. Now, if anybody's sort of thinking, this guy, he was talking about offline use in a minute, how on earth can that work if I haven't got any connection to ArcGIS Online? I'm out in the field. I still want to be able to license my application and use it. Well, luckily we've thought about that. So if that is the case and you are writing an offline application, you just need to write a few extra lines of code. So once you've got your license info, you can basically use a method called to JSON and basically deserialize that into a string. And the idea is you store that string somewhere safely on your device or your machine, so that when your application starts up offline, you get hold of that string, and then from your license info class, you just reserialize that using a from JSON. So you've got that license info now repopulated from the string that you stored safely on your device, which you read when you started it up without any network connectivity, and then it's just a case of calling the set license method with the license info that you've inflated from the string you had on your device. Now these strings will last for a period of 30 days. So as long as your application can reconnect to ArcGIS Online or your own portal every 30 days, you're good to go. This method will work for you. If that doesn't work, so if you're going on an expedition to the Antarctic for 2 months, then you should consider burning a license key into your application so that you're not embarrassed after a month out in the field. So licensed our app. So it's just now a case of using your IDE of choice, IntelliJ or Eclipse, or some people still use NetBeans even, but you will create yourself a runnable jar file that you can then deploy so that it's run in your platform of choice. So this will run inside the Java runtime environment on Windows, Linux, or Mac. Now you have to remember, we're not writing pure Java applications here. The core rendering technology of the runtime, it's written in C++. And that's a good thing because it means that we have consistent rendering of our data, whether the application is running on one of the desktop environments or it may be running on an iPhone or an Android device. It always looks the same because it's the same C++ code that you're running. We just compile it for the platform you're wanting to run it with. So the SDK includes DLL files for running it on Windows, SO files for running it in Linux, and dylib for Mac. Actually, if you were to make a deployment which contained all 3 sets of those binaries, you've got an application that will run on any platform that you deploy it on. But isn't that what Java's all about? We're writing cross-platform applications, but you can choose which platforms that you aim it at. So what we have is a deployment that we've made earlier, which Rachel's just going to talk us through the structure of.
Yes, so you can see in this lower window here, we have our application that's been deployed and is ready to run as a jar file. But before we go into that and try running that, just talk you briefly through the rest of the folders in this directory. This folder here, the samples data, that contains data that is necessary for our jar file to run. And then the core libraries that Mark was just describing are all held within this JNI libs folder in here. So we can take a dive in there and we can see that all the libraries available for the different operating systems are in here, including what we need for this machine, a Windows 64. However, this is one of the most common errors that our users feed back to us, that they are unable to run their jars because they are getting errors appearing within their console, within their terminal, because they don't have the necessary core libraries. So we thought for this demo it would be really useful to show you that error so that if it happens to you in the future, you'll recognize why. That's why this DLL file here for our runtime core Java libraries is broken with a Z file, with a Z letter rather. And if we just go and try to run this jar with the core libraries broken, as expected, we get quite a big error coming up. And the reason that we can't run the jar is because it can't load the library as it's looking for the runtime core Java library. And that's what we expected. So let's go in and fix that. And let's see if we can run our application. Okay, so we're just going to run that sample again. Open up the jar, loading, and then we have our deployed app, which is open and ready to run. And we can do that because we have those core libraries within our folder structure. And Mark's got a demonstration for the same thing, but running on his Mac instead.
So it's exactly the same directory structure. We've got a runnable jar, but the reason this is going to work on a Mac is you see I've deployed the .lib files. So these are the libraries that come with the SDK. So if I just go in now, and I'll run that in exactly the same. I'll do java-jar, and hopefully this should work. So there we have exactly the same application, cross-platform application running on a Mac. Now you'll notice that it's styled very slightly differently. So I've got the traffic light style close buttons as you'd expect to have on a Mac. Or if I was to run this inside a Linux environment, it would be styled for the environment that it's running on. So that's a good thing about JavaFX. It's styled so that it looks like it's running natively on the platform that we're executing it on. Okay, so we'll go back to the slides now. So just to summarize in this session, we've taken you through the implications of writing Java 11 applications. You have to remember that JavaFX is no longer part of the Java runtime environment. We've talked about some of the key classes and the techniques for writing mapping applications, whether they're 2D applications or 3D applications, and talked you through graphics overlays and offline maps, and also explained how you can get your application to market by talking about licensing and deployment. We really only have really touched the surface of the SDK. There's an awful lot more capabilities here, like routing or routing and geocoding, more offline workflows. I do encourage you to take a look at the documentation to get a feel for all the capabilities. But hopefully that's given you an idea on how to get going so you can actually start writing your own applications. Now, before I sort of hand the floor over to questions, I did mention earlier on that we have a new release of the software coming out in about a month's time, should all things go well. We're actually doing final regression testing at the moment. So 100.5 will include annotation and reference scale. So annotation is very good for engineering style applications where you want to be able to have text on your maps, but you want that text to work at specific scales. So that's very useful for companies like utilities companies who want to label important things on their maps, like do not dig here or important information like that. WFS is coming, extensions to KML. We're making some improvements to our offline map parameters. Group layers are coming, so this is something we had in our previous release, which has been asked for over and over again, so we've finally brought that in. And we've got subsurface viewing coming as well. So in the 3D applications that we've had in our SDK to so far, it's been very good at viewing things which are above the ground, but not beneath the ground. But obviously people are interested in things like, oh, where are the wires or the pipes underneath the ground? So we've given you the ability to be able to visualize that. And in the future, we'll be able to extend that so that you can do things like look at geological features under the ground, which my colleague here would be very interested in. So that just gives you a feel for what's coming in about a month's time. So with that, I'll open the floor up to see if anybody has any questions. Yes?
I'm wondering, is this library always intended to visualize data? Because I guess I'm wondering, would it ever be appropriate to use it in like a microservice that doesn't have a UI associated with it? So sort of a contrived example could be like you load up a feature layer in memory on server side, and I pass in some data from a REST service that's a point, right? And I want the service to tell me, does this point exist in some polygon in the feature layer? Yes or no?
Right, okay. So you're talking about using microservices instead of using ArcGIS Online here. So I think you basically have to write you'd have to write the microservices yourself, and you'd have to sort of have your own specification on how you're actually getting the data there. But what you would do is you'd be responsible for putting the things on the screen, the points and the lines or the polygons. And I think the answer is you'd make use of graphics overlays to render that information on the screen. So, which is effectively what we do in the background. So if we're rendering rendering feature service data, we're sort of using exactly the same pipeline as the graphics overlay. So basically, you'd have to abstract your own level of code, which would read the data from the service and render that on the screen. So does that answer your question?
I think so.
Okay.
So you don't have to attach a map viewer to to whatever you're using. You don't have to. It's not required to have a map viewer.
It isn't. No, it's not really designed to work as a headless application, but you wouldn't have to have that information on there. One thing I think you'd be getting into, if you were using the runtime as a server environment, as a microservice, you may be getting yourself into licensing implications there. So you do need to talk to our product management before you go ahead. So I would double check the licensing before you start using runtime as a microservice itself. But as a recipient of data from a microservice, you'd be okay.
Thanks.
Any other questions? Okay, well, thank you very much for listening. If you come and talk to us afterwards, or we're going to be on the developer island until Thursday, so come along and have a chat with us if you'd like to find out more. Thank you.
Thank you.